All right, let's do a word problem with geometric sequences. So, in physics, when a ball bounces, when a ball bounces, the height of consecutive bounces form a geometric sequence. If the first bounce of the ball is 100 centimeters high, and the common ratio of the sequence is r equals 7 over 10, we're going to find the height of the 20th bounce. And so first question is, do we want to use a recursive formula or an explicit formula? Well, if we use the recursive formula, then we'd have to find all of the terms coming up to the 20th before we could find the 20th. If we use the explicit formula, then we can just go straight to the 20th term. So that's the one we want to use. If we needed to know all the heights of all the bounces, I would say, yeah, go ahead and find the explicit formula. It's slightly simpler, especially if you need all of those heights, right? Because you'd just be multiplying by 7 over 10 each time. But since we only need the 20th one, let's go ahead and find the explicit formula and we can go straight to that one. So first, I want to talk about what this looks like. So a ball gets dropped, twing, and it bounces, and then it bounces less high, and then it bounces less high, and then it bounces, and it's going down by the same ratio each time, and eventually it just starts rolling across the floor. So this is not to scale, but that's essentially what is happening. So this is the first sequence we've looked at that's actually decreasing. And it's always going to be decreasing when your ratio is between 0 and 1 or 0 and negative 1. So notice, actually forget what I said about negative 1. It's just between 0 and 1. Between 0 and 1, so if we're multiplying by something that's less than 1 but still positive, right, is what that means, between 0 and 1. So that would be like if I'm multiplying by a half, right, I intuitively know that that's going to be getting smaller each time. So it's the same with anything that's between 0 and 1. It's going to be getting smaller each time. So our 7 over 10 here is between 0 and 1. It's less than 1, but it's positive. So we're getting this sort of decreasing sequence where each one of these would be a height, would correspond with a height, which would correspond with one of the values in our sequence. So let's go ahead and make our formula. We didn't need to know all of that to make our formula. I just wanted to show it to you because I thought it was interesting. To make our formula, all we need to know is that this is the first term and this is the common ratio, right? Because our formula is just an equals first term times common ratio to the n minus 1. And then I want to find a 20, so that's just 100 times 7 over 10 to the 19th power, right? Remember, we're subtracting 1. So to the 19th power. So we're going to put that in a calculator. And we end up with 0.114 centimeters. So after 20 bounces, it's pretty close to the ground. I'd say to the naked eye, that looks probably a lot like rolling at this point. Like maybe barely bouncing, but pretty soon it's just going to start rolling. But we were expecting it to go down, and 20 is a lot of bounces. So this number makes sense. So from the picture, from what we know about balls bouncing, because we've all seen that happen, right? We know kind of what that looks like. This number makes sense. So that's good. It's always good to make sure that your answers make sense when you're talking about word problems. Okay, so that's it for the word problem. And so I will see you in the next video when we talk about the very last part of 9.3.